All right, hello everybody. Happy Thursday. So again, the essential question for today, what would require more work and energy? Driving a car up a gently sloped hill or up a steep sloped hill to the same summit, to the same height? That's what we did in the warm-up. If you were absent, this is the picture for the warm-up. Excuse the glare. There we go. So all the stuff in red is what we filled in class, looking at scenarios 1, 2, and 3. From there, we looked at this interactive, and this is the handout for it. This is page 1. Here's the chart. One of the things that we found, we measured that the force for 30 degrees with a 2 kilogram mass was 9.8 newtons. The displacement was 2.00 meters, and again, you had to convert that from centimeters, 200 centimeters, to meters, and then multiply those two times the cosine of 0 degrees, because the force and the displacement are parallel to each other, so the angle between the two is 0. Cosine of 0 is 1. So we get force times displacement times the cosine of 0, or force times displacement times 1, and that's equal to 19.6 joules. We did that multiple times. We did it for 40 degrees, for 50 degrees, 60, 70, 80, 90 degrees. And again, this was all for a mass of 2 kilograms. So this is what we did in class. For homework, you had to do 4 kilograms as well. And so you should have 2 of these data tables. And then what do we do with this? Well, what we'll do next, scroll on down here. Oops. Scroll this. So the rest of the handout is analysis. So what can we analyze here? Well, we can think about a few things. One, we can think about the force as it relates to the angle. So choose an angle. This could be 10, 20, 30, 40, 50, 60, 70, 80, 90. So we start with 30 degrees. What was the force at 30 degrees? Well, this could be 5, 10, 15, 20, 25, 30. You can choose your divisions here. Think about what would make the most sense, and then plot points and see what you get. See if there's a relationship there between force and angle. Do the same thing over here. Find a relationship between work and the angle. Then, another way of thinking about this is to think about how varying the angle affects the force. So you can think about this in terms of these graphs. You can also just think about the chart that we just made. This chart. And think about the angle, which is listed over here on the left, and the force over here, and think about the relationship between the two. Next, think about how varying the angle affects the work. So there should be a connection there. You should be looking for a pattern. I don't want to give it away, but think about what that is. Next, for number 4, when work is done by an applied force, the object's energy will change, right? This is like in class, I raised something. I raised a roll of tape, gave it more potential energy. So in this interactive, when we do work, are we changing kinetic energy or potential energy? Think about it. One is the energy of motion, and the other is the energy of position. So think about which one, and then explain why you think your answer is true. If you need to, look them up. Look up kinetic energy. Look up potential energy. You can even pull them up on the physics classroom. All right, there's a little search window up there, a little bit higher on the page. Okay, so next thing is to calculate the potential energy of the cart after it's been elevated to a height of 1 meter. How do you do that? Well, if you don't know the equation for potential energy, here it is. Potential energy is equal to the mass times the gravity times the height. Gravity is going to be the acceleration from gravity. So we know the mass, 2 kilograms or 4 kilograms. We know the height, 1 meter. And we know the acceleration from gravity because we've memorized that. And so we can figure out the potential energy. Remember, that energy is going to be in joules. And joules, a joule is a newton times a meter. Let's see, what else? how does your answer to question number 5 compare to the work values in the data table? So the data table was all the way back up there, the data that we collected. So think about that. Does this energy change somehow relate to the work that we figured out, that we calculated here? Remember all these. This one was 19.6, 19.782, 19.65, and you calculated the rest. So think about how that relates for the 2 kilogram and the 4 kilogram chart. And then finally, we want to do a 2-part conclusion. We want to make some statements here, some strong statements, kind of like a hypothesis almost. We want to say something about the amount of force required to pull the cart up the hill at a constant speed and the amount of work that's done when you pull the cart up the hill at a constant speed. So you want to describe how the angle affects those two things. So say something like the effect of the angle on the force is da da da, and the effect of the angle on the work is da da da. All right, those are your sentence starters. So think about that. If you have questions, message me on the Remind app. Finish this up and bring it in Friday, and I'll see you then.